All right, welcome to screencast number 5 of chapter 23, the final chapter. And this is minerals and mining. And here are pictures that just show some of the flood damage because there's nothing that can hold back the water once the mountains have been mined. So you can see the rush of water that's coming down. And then you can see the number of people that protest mountaintop mining. The more I learn about it, the more I don't like it. So the next type of mining that we're going to talk about is called solution mining, and this dissolves and extracts resources that are located in a certain place. Solution mining is also referred to as in situ recovery. And what we do here is resources that are very deep deposits that can be dissolved are dissolved in the liquid and then siphoned out of that liquid. So what they'll do is they'll drill in these narrow holes into the deposit area. They'll add something like water or an acid or other solutions that will dissolve the substances. The substances that they're going to dissolve are going to be like salts and lithium and boron and bromine and potash and copper and uranium. So once they get dissolved, they will suck this all back up, kind of like vacuum it all back up, and then they'll separate it. They'll run it through a separation process. You dry out water that has salt and you're going to get salt crystals. So that's a separation process. So this particular process has less environmental impact than other methods, especially when we think in terms of surface area, because less surface area is going to be disturbed. However, when we consider certain acids and heavy metals and uranium, which we know is nuclear, these can accidentally leak, and if they do, they could contaminate the groundwater. So they're not totally good, but it's a little bit better than most. We're also looking into mining in the ocean. This, I think, with the mountains and then the ocean, this is the second thing that bothers me. I don't know which one actually weighs more, but the oceans hold many minerals, and we can extract some of those minerals just from seawater. So if we could collect seawater, we could extract it. Magnesium salts are held in the seawater solution. There are other minerals that are found on the ocean floor, so they've developed vacuum cleaner type hydraulic dredges that miners collect the sand and the gravel from beneath the sea. They've been able to extract sulfur and salt deposits in the Gulf of Mexico, phosphate, which we know they use for fertilizers, from offshore areas on the California coast. They've also been able to find some valuable minerals beneath the sea floor. Calcium carbonate, which we use to make cement, and silica, which is used for fire-resistant insulation and the manufacture of glass, as well as copper, zinc, silver, and gold ore, have some of the things that have been found underneath the ocean floor. The minerals are concentrated in what we call manganese nodules, and these are small ball-shaped acerations that are scattered across parts of the ocean floor. We think that there's about 1.5 trillion tons of manganese nodules that exist in the Pacific Ocean alone, and their reserves of metals excel all terrestrial reserves. So when we try to consider mining them is logistically not the logistically difficult, I guess is the best way to say it, to mine them. and that's what has kept their extraction uneconomical so far. So we can't get the value of it out of it by the cost that it does to extract them. As land resources become scarcer, we're going to go more to undersea mining as technology develops, and mining companies may turn increasingly to the seas. There are companies already that are exploring the hydrothermal vents, thinking that they have potentially concentrated sources of metals like the gold and silver and zinc in those areas. The vents we know emit dissolved metals resulting from that underground volcanic activity. We don't know the impacts of undersea mining because we really haven't done it, but we can predict that if it increases, it would undoubtedly destroy marine habitats and organisms that have not yet been studied. So that's a problem. It would also likely cause some of the metals to diffuse into the water column, and toxic concentrations could even enter the food chain. So there are some definite concerns with this. So about the mountaintop mining, please make sure that you read the science behind the story. Mountaintop removal mining that's found on pages 644 and 645. So there are things that the government has put into place to try to help reduce the environmental impacts of mining. So the United States and some of our other developed nations, they now require that mining companies restore or reclaim areas that are surface mined following the mining. This is called reclamation, and the whole idea is that it is going to restore the site to a condition similar to its condition before mining. Now, companies are required to remove any buildings that they used at the mining sites. They have to replace overburden. If they've dug in shafts, they have to fill in the shafts, and they need to replant the area with vegetation. So those are some of the things that are required. In 1977, they established a Surface Mining Control and Reclamation Act, and this mandates restoration happens. What it does is it requires the companies to post bonds before mining can be approved to ensure that restoration when mining is done is going to have money to do it. If the company is not successful and they back out, they'll still have the money so that the government can go in and restore the land. Not all nations exercise this amount of oversight. Some are a lot less. One example is the Congo has no regulations at all. So here they are replacing plants in an area where you can see the terrace that was created from mining. So the company has made great strides in reclamation. It employs really hard-working ecologists and engineers to conduct these efforts so that the best possible methods are being used to restore the land. There's still some problems with this because even on sites like you just saw, the impacts of mining can be severe and long-term. You're going to have soil that is water damage and acid drainage, and the reclaimed sites do not generally regain the same biotic communities that were naturally present before the mining. A lot of times fast-growing grasses are used to initiate and anchor the restoration efforts. That does help to control some erosion, and it does allow for a quicker form of outset for some plants, but it can also hinder the long-term establishment of forests and wetlands and other complex communities. Grasses may outcompete slower growing native plants in the acidic, compact, nutrient-poor soils that have resulted because of the mining. Water could be polluted by mining and acid drainage, but this can also be reclaimed. And the way it can be reclaimed is if the pH can be moderated and if toxic heavy metals can be removed. Reclamation of land is challenging and an imperfect process that is used, but we are improving our techniques, and we do need treatment that can be long-lasting. The mines in Spain from the era of the Roman Empire, they are still leaching acid today in the waterways. So we have to find a way somehow to maintain that. Okay, I'm going to just pause this for a minute. Okay, so let's see in the last 4 minutes or so that we can talk about the laws. So in 1872, the General Mining Act was established, and this law actually is still in place today. And this policy actually encourages people and companies to prospect for minerals on federally owned land by allowing the U.S. citizen or any company with permission to do business in the United States to stake a claim on any plot of public land open to mining. So any person or company owning the claim will gain the sole right to take minerals from the area. The claim holder can also patent the claim, which means buy the land, for only $5 per acre. Regardless of the profits they might make on the minerals they extracted, the law requires no payment for the minerals found, any kind, to the public. Until recently, no restoration of the land after mining was even required in this. So the General Mining Act of 1872, the reason why it was enacted, in part, was a response to the chaos that was happening with the gold rush. There were other episodes we talked about that happened in Alaska. So it was designed to bring some order to the mining activities, and it wanted to promote mining at a time when the government was really trying to get settlements in the West and in an orderly way. So the law, they thought, made good sense, but the United States has changed a great deal since then, and many question if the law is suitable for today's nation. So the supporters say, yeah, it's appropriate, it's desirable to continue to encourage domestic mining industry. You got it. They reason with you got to take a substantial financial risk and invest to the local resources and to find those resources because they're vital to the economy. So that's the supporters. And the critics counter that the policies give valuable public resources away to private interest for nearly free. And usually these fall to land development schemes where condominiums was built. So in 2007, the House Representatives passed a bill that would largely end the patenting process and put the public lands off limits. There was in 2009, if it'll let me advance, no it won't. In 2009, it failed to, there was a Hand Rock Mining Reclamation Act, and that failed to get anything done. It just was proposed and nothing happened. So the General Mining Act has remained in place.